Hello all, welcome back. The topic of this video is MTI radar with power amplifier transmitter. This is the block diagram. In this block diagram, if you see, this stereo and coho are the two local oscillators. Stereo is stable local oscillator which generates FL frequency. Coho is also extension is coherent local oscillator, which is also a stable oscillator with frequency Fc. FL and Fc both are supplied to this mixer, forming FL plus Fc, which is the frequency that we use for transmission. As in the previous case, power amplifier will be turned on and off, which is nothing but modulation, amplitude modulating something like pulse modulation, pulse amplitude modulation to the to the carrier signal that is supplied to the power amplifier. This power amplifier will be getting one continuous sine wave with the frequency FL and Fc. Other side, it is a modulator connected, which turns this on for some time and keeps it off for longer time. Again, it makes it on and off. So pulse like carriers are released from this antenna at every pulse repetition time. The signal which goes hits the target and comes back with a Doppler shift. The same signal with a little Doppler shift has came back, which is given to the mixer. The other side of the mixer, the other input of the mixer is derived from stereo, which is FL. FL gets cancelled and Fc plus or minus Fd is given to the IF amplifier, because after the mixer generally signals will get weaker. Now it is made stronger and it is again heterodyned with this frequency Fc. Fc gets cancelled and Fd will be coming out, which is given to the delay range canceller. After delay range canceller, because delay range canceller removes the DC component of the signal and gives you the information about the target locations where there is a movement. This is MTI radar with power oscillator transmitter. This MTI radar is same as we have seen in the previous slide. This same block diagram is again repeated, which is having stereo and coho, having a mixer, and all other things are same. The difference is here, this is trigger generator. This, whenever the trigger generates, pulse modulator produces a pulse, which the pulse modulates this magnetron oscillator. So here output of the magnetron oscillator is nothing but pulse amplitude modulator sine wave or carrier wave, which is given through this duplexer, which is given out to the atmosphere. The received signal with a Doppler shift will come here. From this signal, stereo FL frequency gets cancelled. Here Fc signal will get cancelled, and finally what we get is Fd. The difference between previous diagram and this diagram is nothing but here the role of the pulse modulator, the block diagram pulse modulator is replaced by a magnetron oscillator, pulse modulator and trigger generator. Magnetron, why we use magnetron? Because magnetron is a powerful amplifier at microwave frequencies, powerful oscillator at microwave frequencies. So this is MTI radar with power oscillator transmitter. The output of this circuit is given to delay line canceller. Let us now understand why we need to supply it to the delay line canceller and what is the role of the delay line canceller in MTI radar. Moving targets may be distinguished from the stationary targets by observing the video output on a scope. How will you identify? Again, it is something like integration of radar pulses. You have to observe n number of pulses for some time. Then you will understand where there is a movement. That I will show you demonstrative using this diagram. See here at the location shown by the arrows, this at this place and at this place there are two targets moving. Rest of all the signal is same. Now, because of the movement, there will be a change in the amplitude at this peak and at this peak. This peak is becoming smaller, vanished. Whereas this peak was small, it is raised, and again it is small, it vanished, and it came another way. So, if you give it to an integrating circuit or the adding circuit, then if you write it overlap one on the other, you will get a butterfly like structure in the places where there is a movement in the target. All the rest of all the places, all these peaks are representing the stationary objects, whereas the only place where you get a butterfly diagram is not a stationary target. That target is moving. So a successive A-scope sweeps are shown in the figure A to E, and F is the superposition of successive A-scope sweeps in figure F. Now what will you do? The moving targets produce a butterfly effect on the A-scope. By seeing that, you can understand there is a target which is moving. Now what you do? You put this is that signal which is getting a butterfly diagram at the moving targets. Now this signal you give it to a delay range canceller. One signal S1 will be passed through a delay range canceller. The how much delay? The delay will be of one complete scan. The delay will be of one complete scan. After this complete scan, another signal will be coming. So after the delay, one signal is getting delayed by TP and given to the subtractor. Another signal is directly given. Now what will happen? This signal already went to the subtractor, and in the second wave, the second one will be will be coming from through this delay line. Now 1 minus 2, 1 is also same. See here, what we are doing, we are subtracting this signal from this signal from this signal. What is the variation? All the information where without arrow place, with except the arrow places, all this is same information, except at this place it was medium, here it is sharp high. This is negative sharp high, which has become weaker. All the signal gets cancelled out. Only the difference, wherever there is a difference, that will be displayed on the A-scope. Now that will be displayed on the A-scope, which is called which is the full wave rectifier to make the negative polarity into positive. What we need here? We just need where there is a movement in the target. So we don't need to produce negative lines on the A-scope. So that is why it is called as it was passed through full wave rectifier to convert it to the unipolar video information. These two types of delay range cancellers, what we can do with the delay range cancellers and double delay range cancellers, we will discuss in the coming presentation. Thank you.